Hello all, welcome to the session. I am Sakti Mishra from AWS. I have with me Dhrupajyoti Mandal from Erickson Living. We all know how COVID-19 has affected our day-to-day life, and this topic relates to that, where Erickson Living engaged with AWS Data Lab team to create a minimum viable product in 4 days that helped them automate the data collection, stop the spread with contact tracing, and also build analytical capabilities on top of it. Dhruva and I met through the Data Lab program where we helped them architect the solution. We felt it's a great story to share with the larger audience. That is why we are here today. By the end of the session, you will know if this use case applies to you and how you can build it yourself. Here is a short agenda we will be covering. First, we would like to give an overview about AWS Data Lab and Erickson Living. Then we will see how Erickson Living responded to COVID-19 and how AWS helped in building a technical solution for it. Then we will deep dive into the solution architecture and each of its logical components. Then at the end, Dhruva will cover where they are currently in terms of implementation and what is planned for future. So to introduce myself, I am Sakti Mishra, working as a Senior Data Lab Architect with AWS Data Lab team. To give an overview about AWS Data Lab, it's a program where customers come with an idea and leave with a solution. It's a joint engineering engagement between customers and AWS technical resources to create a tangible deliverable that accelerates customers' data analytics modernization initiatives. AWS Data Lab has two offerings. One is Design Lab, the other one is called Build Lab. Design Lab is a half day to 2 days engagement where customers are looking for real world architecture recommendation based on AWS services but are not ready to build yet. Whereas Build Lab is a 2 to 5 days engagement where customers and AWS technical resources work together to create a minimum viable product, and the output is a working prototype with accelerated steps for production. Customers can engage with AWS Data Lab either through online mode or through 5 in-person AWS Data Lab hubs. There are few prerequisites when customers choose for either a design lab or a build lab. The first one is the business case should be clearly defined and it should have a production deployment planned in next 12 to 18 months. The solution should be having executive sponsorship and the budget should be approved. And it should be based on AWS databases, analytics, machine learning, and AI services. With this, I'll hand over to Dhruva to introduce himself and give an overview about Erickson Living.
Thank you, Shakti. Last year was my first reInvent. You can see me in the picture, pretty excited. Just arrived at the airport. I never imagined that I would be sharing our story at this year reInvent. My name is Dhrupajyoti Mandal. This is my 12th year at Erickson Living. Erickson Living is one of the nation's most respected leaders in building and operating continuum care retirement communities. I'm an application architect at Erickson Living. We get to work on an exciting project to support our residents' day-to-day activities. We have an ecosystem of apps that let residents track events, menu across the community right from mobile device. We also enable telehealth functionality this year. We created a training hub, a video sharing platform on AWS. This year, we also decided to build an outbreak management system to manage COVID-19. Internally, we call it Infectious Disease Management System, or in short, IDMS. In the next slide, we'll look at all the requirements for IDMS. The goal was to manage every aspect of outbreak. It may sound easy, but we quickly realized it's a complicated process. I'm glad we spent a week breaking down the requirement in manageable groups. Our business partner and business analyst did an excellent job helping us identifying the system requirements. For today's presentation, we will divide the requirement into 4 high-level areas. First is intake. We have 19 communities within 27,000 residents and 15,000 employees. We needed an intake triage system that will quickly record an incident related to COVID or any other infectious disease. Once an episode is created, IDMS should be able to track the person's progress and finally clear them from the infection. We're calling this as the intake module. Second, we needed a contact tracing module. Contact tracing is the process of identifying residents and employee who may have come in contact with an infected person. Contact tracing is also used to track the type of infection to determine the risk factor. For example, if the person was wearing PPE during the interaction. We also track how long was the interaction. Any additional information always helps identifying the risk factor for spreading the infection. Third was we needed one single source of truth. I mentioned we have communities across US. We needed all of that data available for corporate while maintaining separate community process control. We also wanted a quick user onboarding using our SSO infrastructure. And the last group in the requirement, we needed to make sense of the situation from the data. Only way to identify that we need next mass COVID testing is through reports. We also need a report for regulatory purpose, so analytics is a big part of the requirement. To recap, we talked about intake, contact tracing, one source of truth, and analytics. Next slide, we'll talk about overall solution. So let's see what we did for intake. Erickson Living has a robust integration platform. All demographic data flows through the integration platform. IDMS gets employee and resident feeds through our integration. User can log into intake module using SSO, search for a resident or employee, and create a new COVID episode. User can also add other details to episode through a web interface. We are using Elasticsearch for a quick access to resident and employee records. In the contact tracing module, user can open an episode and link resident and employees to the episode. We also allow user to add additional interaction details. The graph database is extremely efficient in handling this kind of connected data. We use Amazon Neptune graph database to record the connection between resident and employees. For a single source of truth across the community, we use Amazon DynamoDB as the primary database. We use the auth directive at AppSync for restricting access across community users. We leverage Cognito's SAML integration to enable SSO. For analytics, we were able to use on-prem application as well as Kibana and QuickSight. Next, Shakti will walk us through the solution components.
Thank you, Dhruva. So as you all can see, these are the 5 major components of the solution architecture. The first one is the web frontend. This is built with React.js and is integrated through AWS Amplify. This also integrates Amazon S3 for web static assets and Amazon CloudFront for CDN. The purpose of the web frontend is to automate the data collection. This helps Erickson Living to collect data about their residents and employees. The second component we have here is application storage, which is backed by Amazon DynamoDB as a transactional data store and Amazon Elasticsearch for faster search. Once you have the data available in the front end, that gets synced back through DynamoDB and Elasticsearch. The third component we have here is AWS application integration that integrates AWS Lambda, which syncs the data between multiple storage layers. Once the data is available in DynamoDB, which is the backend of the web frontend, it integrates the data between information graph, data lake, and the Elasticsearch service. The fourth component we have here is data lake reporting. Once we have the data available in the S3 landing zone, the both demographics data and non-demographics data from the web frontend, now we need to build analytics on top of that to derive insights. So once the data arrives in raw landing zone, we have integrated AWS Glue for ETL transformations. And then on top of that, we have integrated Amazon Athena as an interactive query engine where users can execute standard SQLs. Then we have integrated Amazon QuickSight for business reporting. The final component we have here is information graph. As Dhruva said, contact tracing is a major piece of the architecture, and we were looking for a graph database solution. And we found Amazon Neptune was a great choice for it. With this, I'll hand over to Dhruva to walk us through the solution architecture and each of its logical components.
Thanks, Shakti. Here we'll see how solution components are grouped. It's very simple. We collect data through a web application. That is our intake and contact tracing module. Everything that is recorded as part of the application processed using AWS Lambda. That is our data processing group. And the last group is the analytics solution portions. Later, Shakti will talk about analytics architecture. Now, in the next slide, we'll explore the architecture. I want to mention a couple of things before we deep dive into the architecture diagram. The entire application is built using Amplify. The application side is also serverless. Whenever possible, we use managed services. For data processing and analytics module, we did not use Amplify, but for the rest of the application was built using Amplify. Now let's look at the architecture diagram. The lower right side of the web application, this is the data collection part you just saw in our previous slide. If you move from there to the left, you'll see multiple lambdas used for data processing. And one in the top shows the analytics. During the actual lab, we divided our team into 3 groups as well. That was helpful, and it was vital to have an end-to-end prototype quickly. During Data Lab, first 3 days, we focused on building each component, and 4th day was used to integrate all 3 logical components. In the next slide, we'll zoom in on our first logical component. So this is the data collection / web application portion of the architecture diagram. Let's start with authentication. For single sign-on, we use Amazon Cognito. We have Ping as an identity provider. We host our React app on Amazon CloudFront using Amazon Simple Storage Services as the origin. We created a Cognito user pool with a hosted UI setup to allow authenticated user to log in. We also added S3 storage to upload attached document related to an episode. For the persistence layer, we decided to go with a combination of Amazon DynamoDB and Amazon Elasticsearch services. DynamoDB supports document data model. It helped us to adapt to the change in requirement. We were getting changes in requirement almost on a daily basis. We were able to accommodate new attributes very easily. Just modify the GraphQL schema, redeploy the application, and that'll change the API to accommodate additional attributes. DynamoDB low latency read response, typically within 10 to 20 seconds, worked in our favor. IDMS users was pleased with the performance, and Amazon DynamoDB is well integrated with other AWS services, and that was a huge benefit in terms of integration. Amazon Elasticsearch is another persistent technology we used in our project. In the application, we created a role-based queue to look at residents and employees in various stages of infection. We used Amazon Elasticsearch services to build the queues. Once the user creates a record that gets stored in Amazon DynamoDB, we take advantage of streaming to add an index to Elasticsearch. Our data model consists of demographic information, symptom data, lab, location, travel, infection, and test information. All our data is queryable using Elasticsearch. The user gets instant search information as they are typing. Another advantage with this architecture, we can also use Kibana for visualization. And Kibana is configured as part of Elasticsearch. So there was no additional setup required for Kibana. GraphDB is a third type of storage technology we are using in our application. In the requirement, we talked about contact tracing. Contact tracing information is highly connected data model. In AppSync, we use Lambda as a data source. Then Lambda connects to Amazon Neptune. We created a recommendation engine with just a simple query of adjacent nodes. We have more data points available for integration with Neptune database. Our contact tracing recommendation will get better with more connected nodes. In the next slide, we'll look at data processing. Moving on to the data processing section, we use AWS Lambda as microservices. Whenever someone joins our company, we have an integration to make it available to S3 bucket. We have set up a trigger to insert record from S3 bucket to DynamoDB using Lambda. This cut down on our manual data entry. A new person is available in IDMS near real time. We also have Lambda that gets triggered by DynamoDB. We're collecting hundreds of attributes related to infectious disease. Those attributes are grouped into 11 documents. We have 11 different lambdas that get triggered and delivered the same message into the S3 bucket. Once the data is in S3 bucket, on-prem application downloads a JSON file for reporting. At the same time, JSON records are also available for analytics. Now, Shakti will talk about how JSON is consumed and used in the analytics sections.
Thank you, Dhruva, for diving deep into the data collection and data processing part. Now let's deep dive into the data analytics piece. Now, before we go into the architecture, let's understand the objective of this architecture piece. So we are collecting data from the on-premise demographic data, and then we are also collecting non-demographic data from the web frontend. The objective is to derive insights on top of the data that can help the business team for faster decision making. Now, if you look at this architecture here, the first component on the left side is the Amazon S3 landing zone. So we are receiving JSON data from the web frontend as well as from on-premise. And then on top of that, we have integrated AWS Glue as a ETL transformation layer, which converts the JSON to Parquet format, applies few transformations, and then finally writes to the data lake bucket in Apache Parquet format. Now it's a good time to give an overview about AWS Glue. So AWS Glue is a fully managed ETL service that helps customers to design ETL pipeline with few clicks on the visual interface, which is AWS Glue Studio, that auto-generates PySpark or Scala code. So AWS Glue is built on top of Apache Spark engine. It gets all the in-memory distributed processing capabilities. I'll add few additional benefits or features of AWS Glue, which are adding a great value. One is called job bookmarks. So once you receive your incremental data sets into your raw landing zone, you will always have a need to only process the incremental data, not the whole historical data. Job bookmarks solves that particular problem statement where it only picks up the new incremental data sets by keeping an internal tracker what it has processed last time. Glue also provides Glue workflows, which helps in building an orchestration pipeline that chains Glue crawlers and jobs either sequentially or in parallel. Now, if you look at the middle part of the architecture here, we are talking about Glue crawlers and catalog. Here, Glue crawlers auto-detects the schema from either the raw landing zone or data lake by scanning subset of data and creates a virtual table in Glue catalog. Now, once you have the virtual tables available in Glue catalog, we have integrated Amazon Athena here, which acts as an interactive query engine where users can execute standard SQL queries to fetch data from the data lake. Amazon Athena is completely serverless, where you pay only for the amount of queries you execute, and it is out of the box integrated with AWS Glue Catalog. Amazon Athena is built on top of Apache Presto, and it also integrates Hive as a DDL. Then at the end, we have integrated Amazon QuickSight for business intelligence reporting, which is a fully managed, faster business intelligence service where you can create reports and dashboards that you can share with anybody in your organization, or you can integrate easily in web reports or websites. So as you can see here, we have this ETL pipeline where at the end we have reports getting built on Amazon QuickSight, and the workflows are built through Glue workflows. Now let's talk about few of the optimization techniques when you build a data analytics pipeline with Amazon S3, AWS Glue, and Amazon Athena. So the first one we are talking about is the storage format. So you have different storage format options when you store data in the data lake or your raw landing zone. It can be CSV, JSON, Avro, ORC, or Parquet. For our use case, we have selected Apache Parquet, which is a columnar format, just because we have most of the queries as analytical queries, which does column level operation. So we are getting performance benefit as well as storage savings from the Apache Parquet format. The second optimization technique we can talk about is the partitioning on Amazon S3 or Data Lake. Now, once you have all the data arriving, you can store all of them in one folder or bucket, but that is not recommended. If you know your query pattern, if you know you will be filtering your data on a particular column, it's better you follow partitioning where you distribute your data between partitions and subpartitions. For our use case, we have used year, month, and day as our partitions and subpartitions, which means if you are executing a query that filters out your data by a year and month, Amazon Athena will only look at the subset of data available in that subfolder, where you are not scanning the whole amount of data and you are getting performance benefit as well as cost benefit. Because Amazon Athena's pricing is based on the amount of data is scanning while it is querying. So with this, I'll hand over to Dhruva again to walk us through a few of the application screenshots and also explain where they are currently in terms of implementation and what is planned for future.
That was great, Shakti. It reminds me of our first day in Data Lab when you walk us through the same content. Anyway, as Shakti mentioned, this is one of the visualization of the contact tracing records. The person icon with the red dot is the main record. We can see two other people came in contact with the main record. You can also see two other people were in the same location at the same time. And for the high-level navigation, if you look at the right side, that's navigation for the entire application, and the left side navigation was meant for the detailed record. In the next slide, we'll see one of the visualization from the testing. Imagine someone who got infected was visiting the dining area, and that might trigger in mass testing. This screen shows how we will manage the testing data, and corporate can take decision based on that. In the next slide, we'll recap where we are today. So we have a one-of-a-kind contact tracing module. I'm very proud of that. We have 40,000 employees and residents as part of the system. We can get instant access to their record through a web interface. We can manage the entire episode of infection and return them to work. We can track asymptomatic mass testing data. So where do you go from here? We can use visual ML to improve our recommendation logic for contact tracing. We also talk about self-service as an option that will reduce huge burden on our employees. In the next slide, I'll talk about my experience with the Data Lab. We spent 4 months building this application. We built this in 4 months because we could create a prototype within 4 days during our lab. We started with the use case. We were able to secure the engagement within weeks. During the prototype, we came up with the architecture and working solution. We also got the opportunity to explore new AWS services used in our architecture. Shakti did an excellent job guiding us through the entire process. I can say with confidence, this is a great model to jumpstart a project. That brings us to the end of my presentation. Thank you for listening, and I'll hand it over to Shakti for closing comments.
So we are at the end of the session. Thank you all for joining. If you have any questions or you would like to discuss more about the use case, please reach out. We have our LinkedIn contact on the screen. We will be happy to help. Thank you again for joining. Hope it was helpful. We will have a short survey at the end. If you can complete that, that will be great.